Welcome all. In last lecture we have studied regarding design of multiplexer trees and use of multiplexers in the combinational logic design. Today we are going to study about demultiplexer. Demultiplexer is also a special type of combinational circuit. The block diagram of 1 is to n and its equivalent circuit is shown in the figure. The demultiplexer is having only a single input and multiple outputs, and the available single data input will going to appear on any one of the output lines depending on the status of these select lines. There is a enable input terminal available which enables or disables the given demultiplexer. After enabling, only the available data input will going to appear on the selected output line. When the demultiplexer is disabled, we will get a default zero output over the output lines of the demultiplexer. This is the equivalent circuit of the demultiplexer, which shows the data input is selecting any one of the output lines depending on the status of select lines, and it going to appear over the selected output line. Now we will see the types of demultiplexer. One more point over here is the demultiplexer is exactly demultiplexer performs operation exactly opposite to that of multiplexer. The multiplexer is many input to one output, whereas demultiplexer is a single input to many output. These are the types of demultiplexers: 1 is to 2 demultiplexer, 1 is to 4, 1 is to 8, and 1 is to 16 demultiplexer. The 1 is to 2 demultiplexer is having one input and two outputs, that is n is 2 for this case. So here we are going to decide number of select lines from the number of output lines using the same formula. N is less than or equal to 2 raised to m. Here n is, that is output line, is 2, less than or equal to 2 raised to m. Comparing powers of 2, we will get 1. So for 1 is to 2 demultiplexer, number of select lines will be only 1. Now second is 1 is to 4 demultiplexer. Here number of input is 1 and number of output lines are 4, that is n is 4. So again we can find the number of select line using the formula. N is less than or equal to 2 raised to m, 4 is less than or equal to 2 raised to m. This 4 can be written as in the form of 2 raised to power, that is 2 raised to 2 is equal to 2 raised to m. Comparing powers of m, we get m is equal to 2. So 1 is to 4 demultiplexer will have two select lines. Now next is the 1:8 demultiplexer, which is again having single input and 8 output lines. That is, here n is 8. Here again we can find number of select line using the formula n is less than or equal to 2 raised to m. 8 is less than or equal to 2 raised to m. We can write this 8 in the form of 2 raised to power, that is 2 raised to 3 will gives you 8 equal to 2 raised to m. Again comparing powers of m, we will get number of select line as a 3. So 1:8 demultiplexer will have 3 select lines. The next demultiplexer type is 1:16 demultiplexer, which is having one input, single input, and 16 output lines. That is, here n is 16. So again we can find the number of select lines using this formula. So here n is 16 equal to 2 raised to m less than or equal to 16 can be written in the form of 2 raised to power as a 2 raised to 4 less than or equal to 2 raised to m. Now here again comparing the powers, we get m as a 4. That is, number of select lines for the 1:16 demultiplexer will be 4. Now we will see one by one the design of these demultiplexers. First is the 1:2 demultiplexer. The block schematic is shown in the figure. This is a block schematic of 1:2 demultiplexer. It is having a single input, that is one input, and two outputs. These are the two outputs, y0 and y1. Therefore the value of n for this demultiplexer is 2. Now based on number of output lines, we can find the number of select line using this formula as we discussed in the previous slide. So we get m as a 1 for this 1:2 demultiplexer, that is select line named as a S0. This demultiplexer is having a enable input line, that is E, which will enables or disables this demultiplexer based on the value of input available to the enable input terminal. This is regarding block schematic of the 1:2 demultiplexer. Now we will see how to get the logic diagram for this one. So the truth table of 1:2 demultiplexer, which is having enable input line, select line, and output lines. For the first case, the enable input is 0. So irrespective of data input and status of select input, either it may be 0 or 1, we will get a default 0 output over the all the output lines of the demultiplexer when enable input is 0. So we can say that when enable input is 0, the demultiplexer is in off state, or it is a disabled. Therefore we will not get any data over the output line. Whereas when enable input is 1, depending on the status of select line, we will get a data over the output line. So when enable input is 1, status line is 0, then we will get a data over a y0 line. And when enable input is 1 and status of select line is 1, then we will get the data over a y1 line. So we can say that when select line is 0, it will select a y0 line. When select line is 1, it will select a y1 line, and the data input will going to appear over the selected output line. This is the elaborated truth table in which actual values of data input are shown. The first condition, enable is 0, so irrespective of available data input, irrespective of status of select line, we get a 0 over the two output lines. Again, here when enable input is 1, data input is 0, select line is 0, so we will get this data input over the y0 line, and we will get a default 0 over output y1. When enable input is 1, data input is also 1 here for the second case. Status of select line is 0, so y0 line is going to be selected, and available data, that is 1, will going to appear over y0 line, and y1 will remain as a 0. Again, for next case, enable is 1, data input is 0. Now select line is 1 over here, so it will select a y1 output line, and the data input 0 will going to appear over y1, and y0 will be 0 by default. For the next case, enable is 1, data input is 1, select line is 1, so this data input 1 will going to appear over the y1 line, and y0 line will be 0. So when select line is 0, a y0 is connected to data input. When select line is 1, a y1 line is connected to data input. So if we observe this, we can get equation of y1 and y0 using K-map. Actually, there is no need to use a K-map over here, as we will not get any octet, quad or pair for any of the demultiplexers. So to get understand only, here the K-map is used, that how a output equation will be can be taken. So here the enable input, data input and select input are, these are the input lines. So in all there are 3 input lines, so 3 variable K-map is used over here. y1 and y0 are the 2 output lines, so for each individual output a K-map is constructed. We know already how a 3 variable K-map can be used. Here enable line is taken vertically, and data input and S0 lines are taken horizontally, and values from this y1 column are inserted over this K-map. So here only for E1, data input 1, S0 1, we will get 1. So the cell position is over here, and as we will not get any quad, octet or pair, so for this one, whatever term is available over here, over there, it is written as it is, that is the cell position is 1. For this, enable is 1, D in 1, S0 is also 1, so Y1 is written as E D in S0. For Y0, 1 is over here, that is E D in and S0 bar, so E D in and S0 bar. The cell position is over here, so 1 is entered over there, and remaining cells contain 0 as the output is 0 for remaining input combinations. So for Y0 we get the term as E D in S0 bar. So we get the two output line equations. From that we can draw the logic diagram. So this is the line of E variable, this is the line of data input, this is the line of select line, that is S0, and this is the line of S0 bar. So to get Y1 we use a AND gate. To that, E input, data input and S0 inputs are connected. This is Y1, where we get a Y1 output. To get Y0 we get another AND gate, to which enable input, data input and S0 bar line connected to get a Y0 output. This is how we can design a 1:2 demultiplexer. Next we will see a 1:4 demultiplexer. Block schematic is shown in the figure, which is having a single input and 4 outputs. These are the 4 outputs: Y0, Y1, Y2, Y3. Therefore value of n will be 4, and number of select lines can be calculated from the number of output lines using this formula, n is equal to 2 raised to m. So putting the value of n into this equation, we get number of select lines as a 2. So the number of select lines are S1 and S0. The enable input line is available to enable or disable the given demultiplexer. This is the truth table, which contains enable input line, data input line, 2 select lines. Depending on the status of select lines, any one of the 4 output lines get selected and available data input will going to appear on the output line. Here for the first two cases, S1 and S0 are 0 0, so Y0 line is connected to data input line. For the next two cases, S1 and S0 lines are 0 1 over here, so Y1 line is going to be connected to the data input. For the next two cases, S1 and S0 lines are 1 0, Y2 is connected to data input, and for last two cases, S1 and S0 are 1 1, so a Y3 line is connected to the data input. Here enable input is 1, so the demultiplexer will not be disabled, that is it is enabled, as enable input is 1. So the available data input can appear over the selected output line. So if enable input line is 0, then irrespective of data input and irrespective of status of select line, we will get a 0 output over the all output lines. So here that condition is not shown in the truth table, only a high input enable terminal condition is shown in this truth table. So we have to find output equations of Y0, Y1, Y2, Y3. So for that we will use a K-map, as here we are going to consider the 4 input variables: E, data input, S1, S0. So we will use a 4 variable K-map to get output equation. This is the K-map for output Y0. Only a single one is available over here for 1101 condition. So 1100 condition. Now in this Y0 column, here it is 1 for which input combinations are 1100. So 1100 is over here, so we will get the cell position, this one is entered over there and remaining cells contain zeros. So for that, the term will be S1 bar, S0 bar, E D in are vertically, S1 S0 are horizontally. For Y1, the output is 1 for the input combination 1101. Here it is 1101 cell position, remaining cells contain 0. So for Y1 we will get the equation as S1 bar, S0 bar, E D in. In the same way, for Y2, the entries are made available over the K-map, and for Y2 we will get the equation as S1 S0 bar E D in, and for Y3 we will get the equation as S1 S0 E D in. From these four output equations we can realize the 1:4 demultiplexer, for which we require 4 AND gates to get the related output term. This is how we can design 1:4 demultiplexer. Next we will see 1:8 demultiplexer, which is having a 1 input 8 output Y0 to Y7, that is n is 8. So using this formula we can find number of select lines, which we will get a 3. So 1:8 for 1:8 demultiplexer, number of select lines will be 3. This is the block schematic, which contains single input, 8 outputs Y0 to Y7, 3 select line S0, S1, S2, and enable input for the on and off of the demultiplexer. This is the truth table of the 1:8 demultiplexer. So using K-map we can find the equation of each output line, and we can realize the 1:8 demultiplexer in the same way as we have realized 1:2 and 1:4 demultiplexer. Next is the 1:16 demultiplexer, which is having one input. Sorry, here by mistake 8 is written, actually it is 16 output lines. It contains Y0 to Y15, so n is 16, and depending on the value of n, a number of select lines can be decided. In this case m will be 4, so for the 1:16 demultiplexer, number of select lines will be 4. So this is the block schematic of the 1:16 demultiplexer. Single input, 16 output Y0 to Y15, and 4 select lines and enable input pin. So we can realize 1:16 demultiplexer in the same way as we have designed 1:2 and 1:4 demultiplexer. Now we will see the demultiplexer IC, which is a 16 pin IC, and it contains dual 1:4 demultiplexer. That is, there are two 1:4 demultiplexer available in a single IC. Now this table shows the pin numbers and respective functions. Now for to 1:4 demultiplexer, there are single inputs to each. The C1 is for first demultiplexer and C2 is for second demultiplexer. These are the data input lines, and for each demultiplexer a strobe input or enable input line is available. This G1 is for first demultiplexer and this G2 is for second demultiplexer. For each demultiplexer, number of select line will be 4. Here a common select lines are shown at pin number 3 and 13. A and B, these are the two select lines of both the demultiplexers. You can find these pins over here. Now for first demultiplexer, 4 output lines are 1y3 to 1y0, and second demultiplexer, 4 output lines are 2y3 to 2y0. Pin number 8 is grounded and pin number 16 is supplied with the plus VCC. So these are the 4 output lines of first demultiplexer. These are the 4 output lines of second demultiplexer. This is the input line of first demultiplexer C1. This is the input line of second demultiplexer C2. These are the ground and VCC connections. Strobe G1 is the enable input line of first demultiplexer. Strobe G2 is enable input line of second demultiplexer. Select input A and select input B are the select lines of both the demultiplexers. This is how a simplified block diagram can be seen in the IC 74155, which contains two 1:4 demultiplexers, this one and the second one. Here the common select lines are available for both these demultiplexers. These are the 4 output lines of first demultiplexer. These are the 4 output lines of second demultiplexer. The data input line of first demux, data input line of second demux, strobe input line of G1 and strobe input line of second demultiplexer. Here the strobe input line is a active low input terminal, that is it will be active when it is grounded. So to enable the demultiplexer we have to provide a ground connection to the strobe input so that available data input can be available over the selected output lines. This diagram shows the connections of IC 74155 as a 1:4 demultiplexer. The data input line, the 4 output lines. Here strobe input line is connected to ground, that is its value is made 0, active low. So by connecting a G1 line to ground, we can observe the data input over the selected output lines depending on the status of these select lines. Thank you.